SULAM, which is also known as Service Learning Malaysia University for Society, is a program that has introduced by the Ministry of Higher Education in 2019. The purpose of introducing SULAM is to demonstrate a multidimensional concept that embraces curriculum and co-curriculum of pedagogical approaches to surveys and educational opportunities through Malaysia Education Blueprint 2015 to 2025. This integrates the academic learning with community surveys, promoting sustainability and enhancing student development. Our SULAM project falls under the theme Application of Spectroscopic Separation and Electrochemical Methods in Sustainable Water Resource Management, while our group demonstrated electrodegradation, which is an electrochemical process that breaks down the pollutants in water using electricity. So, speaking of electrodegradation, it is an effective and environmentally sustainable technique for treating harmful substances in water or wastewater. This process uses electrical energy to drive chemical reactions at the electrode surfaces, which helps to break down the pollutants such as dyes into simpler, less harmful or inert byproducts. Consequently, this method offers an efficient and green way to remove the dyes from contaminated water and improve the water quality. There are several objectives of this SULAM project. Well, one of the objectives is to introduce the Form 2 students from SMK Stream Muda Benaga about the concept of electrodegradation as an electrochemical water treatment method. The next objective is to determine the effectiveness of electrodegradation in removing colored dye rate 4 in contaminated river water. While lastly, we aim to enhance the awareness about water pollution and sustainability among the youth to protect the local environment.
During the activity, we began by introducing sources of water pollution, the importance of clean water, and the electrodegradation process to the participants. The experiment started by dissolving sodium sulfate in river water to act as the electrolyte, followed by the addition of the dye to create dye-contaminated water. Then, both graphite electrodes were placed about 3 cm apart and connected to a 12-volt power supply. Once it switched on, students observed the bubble formation and color fading over time. Finally, the treated water was filtered after 6 minutes. Through this hands-on activity, Form 2 students learned key concepts such as electrolysis, oxidation at the anode, reduction at the cathode, and how chemistry can be applied to solve real environmental problems. These are the results obtained through the electrodegradation process at 0 minute and after 6 minutes. At the 0 minute, the solution was turbid with a strong pink color and no gas bubbles were observed, while after 6 minutes, there were gas bubbles formed at the electrodes, which indicated electrochemical reactions were occurring. Hydrogen gas was released at the cathode, while oxygen gas was released at the anode. As a result, the water became clearer and the dye color intensity was significantly reduced. This happens because oxidation process at the anode produces hydroxyl radicals, which break down the azochromophore in the reactive red dye. Therefore, these reactions confirm that electrodegradation effectively removes the dye and improves water clarity. Throughout this SULAM project, students had learned about electrodegradation and electrolysis, including oxidation and reduction reactions. By observing the dye removal, they became more aware of water pollution and how it can be treated scientifically. And next, our group had learned how chemistry can be applied to treat polluted water. And through this project, we had improved our ability to communicate scientific concepts in a simpler way while developing teamwork, communication, and experiment planning skills. And finally, regarding on the sustainability impact, electrodegradation can remove synthetic dyes efficiently with fewer chemicals and less waste produced, which helps to manage water resources sustainably.
Thanks to Rachel, I'm Tan Jingwei. Now I will be presenting the part about expected outcomes. Results. The color of the solution's red relative flow will fade quickly as the dye molecules are oxidized and degrade through hydroxyl radicals and direct electron transfer. We are able to observe and interpret electrochemical reactions that occur at both anode and cathodes. At the anode electrode, oxidation occurs when H2O molecule will degrade to OH radicals and break down the reactive rate 4 to carbon dioxide and H2O molecules. We are able to notice bubbles that form around the anode electrodes. Besides, no coagulations form at the electrode instead of degradations. Consequently, the water becomes visibly clearly as the pink color solutions is gradually fading and improve the water clarity. What students learn? Students are able to gain both scientific understanding and practical skill. Students are being clear that electricity can be used to treat and clean polluted water through simple chemical reactions. Students are included the awareness of being environment friendly into them as this can connect what they learn in class to the world around them. Secondly, I will be present what challenge we face during the day. From two students are lack of the knowledge and information about electrolysis. Therefore, we need to explain the concept and ideas in a simple and relatable ways to reflect deeply on our understanding and think creatively. We are like explaining those knowledge in an easy understanding way to a 5 years old child. The younger generation is not understanding the importance of learning science in our life. Through this experiment, electrochemical reactions can effectively treat contaminated water, which can cause positive impact on the environmental and society. Therefore, it promotes awareness of environmental responsibility among students and knowing the importance of learning chemistry in their life. Last challenge we face is lack of engagements between facilitators with the students. Therefore, presents such as candy is given for those who are actively giving response and answering. Now, I will pass my part to Jia En. Thank you.
Based on the feedback collected, the response from the Form 2 participants was overall very positive. Most students were interested in observing the visible color change of the reactive rate for dye, as it clearly demonstrated the process of water purification. This activity helps students better understand redox reaction and the role of electricity in chemical processes. Additionally, students could connect chemistry concepts to real environmental issues such as water pollution. From the teacher's perspective, the activity was effective in strengthening classroom learning, especially for topics such as electrochemistry and redox reactions. Teachers observed that students were more curious and attentive compared to normal classroom lessons. They also highlighted that the abstract chemical concepts easier to understand through hands-on activity. Overall, the activity helped students link classroom theory to real-life situations and increase their awareness of the importance of protecting water resources. In conclusion, this SULAM project successfully demonstrated the application of analytical chemistry, specifically electrodegradation, in managing water pollution sustainably. Through the experiments, students were able to understand the impact of synthetic dye on the environment. At the same time, the project allowed our group to gain hands-on experience in applying electrochemical concepts, planning experiments, and communicating scientific ideas to the younger audience. For future improvements, the activity could include quantitative measurements such as monitoring dye concentration over time. Expanding the program to more schools or community groups would also increase its impact. Additionally, integrating simple digital tools or sensors could enhance data accuracy and student engagement. Overall, this project shows that combining science education with community engagement is an effective way to promote environmental awareness and sustainable practices.